Hello, good afternoon. My name is Christian Nicholson. I have with me
Lee Salter.
production process leader and process support from Assembly. Today we're going to discuss some points around Industry 4.0 and how that looks like in the automotive industry and what then is the next step beyond Industry 4.0. To start off with then, I'll talk a bit about the business. So within the business of the automotive industry, certain aspects of Industry 4.0 encapsulate is really digitalisation, which is ingrained in the concept of a smart factory. So digitalisation could be the integration within value chains, digitalisation of product and service offerings, and digital business models and customer experience. That's really how information flows between the supply chain, from the supplier through to manufacturer through to the end customer, and likewise how data can go back upstream. Within the manufacturing business, there's a model on the right that has an overview of a connected factory. And the smart factory has four main aspects. One being, or the first being innovation, so integration of cybernetics, 3D printing and visual aids. Efficiency, businesses have to be more efficient in the current climate, and one way to do that is through visual KPIs, OEE and lean manufacturing strategies. Third section of a smart factory is agility, so expandable infrastructure and a fully connected supply chain, so how quickly you can adapt to changes in market trends. And the fourth group being risk. So whilst there can be maybe the physical side being health and safety, the flip side could be cyber and physical security, which is becoming increasingly more prominent within all industries, so how you protect data. And likewise how within the manufacturing sphere, how you can proactively predict when machines are going to either break or need servicing and maintenance. And these are really the areas of certainly manufacturing and the business of manufacturing are most prominent within Industry 4.0 in the current climate.
As has already been touched on previously, one of the aspects of Industry 4.0 is a trend towards automation and the amount of data being collected as well within the manufacturing environment. So it's led to the integration of many new logistic technologies to help embed in the just-in-time delivery system. To better explain the advances that have been made, the first internal combustion engine was made in 1859 and put into successfully commercialised in 1886. In 130 years, that is still a fundamental part of Rolls-Royce business through our core product and also transport methods. But going forward into Industry 4.0, the autonomous side is now coming out both in the public forum and in delivery concepts as well. The benefit to this is, with technology advancing, this leads to a greater social mobility as well. So geographically, whereas previously industry used to be in set areas, it opens up a wider variety, simply due to the fact that it gives a greater flexibility and flexibility during the geographical movements of both staff and skill set. With data generation at its core of Industry 4.0, it represents a potent opportunity. Data has never been collected in the format or the amount being collected at the moment. This is basically the key driving feature that everyone and everything is connected in real time. So that means resolution can also be quicker and also detection. Obviously the flip side of this is that this data needs to be very secure at all times, because it's in the core part of all businesses. Rolls-Royce need to embrace uncertainty both in the marketplace and the ambiguity within the manufacturing environment as well. With the data generated, it will assist in meeting these tasks and also the market fluctuations. It takes several forms. The key approach to the data generator is also tied in through the VPS principles to use within the production lines of Rolls-Royce motor cars. Each station has its own detailed data set given to them in a real-time environment. This helps hopefully contain issues on a lot faster basis, and also protects the integrity of the product, because we can ensure that we detect our first possible opportunity. So efficiency and agility, as long as you follow these routes, the efficiency will increase. As each industrial phase of the industrial revolution has progressed, the efficiency has been a key part to it. We've gone from steam powered all the way up to where we are today, and slowly transitioning into Industry 5.0. Every step, the less efficiency or the more efficiency you can eradicate, the better it sits in with the smart factory criteria. We use various tools like Six Sigma, etc., and also focus on the importance and ability of the workforce and skill set. As everything progresses forward, new technologies come in, new processes, and also new requirements as well. Because it's now a global market, so we have to make sure that we meet those demands. Thankfully, the agility understands that this is required within the manufacturing environment. It also depends on the employer's employability as well. We need to make sure that we maintain a good employer as part of our strategic matter and absolute urgency when faced with the severity of fast-paced change in the manufacturing automotive environment.
So one aspect of the fourth industrial revolution, or Industry 4.0, within, or that's certainly relevant within manufacturing, is scalability. There's three aspects that really define what scalability looks like. The first being a flexible and convertible configurable production facility. So as I mentioned initially at the start, manufacturing facilities have to be very block structured to enable them to change and tweak as with the market fluctuations. So depending on the product offering, depending on what it needs to, the production line has to be able to react and change to those offerings. One such example of that within Rolls-Royce is we've recently gone from a two-line production system to a one-line or a straight-line production system, which has aided in our ability to be able to send any model down the production line without fail, and it can be built. So the advantage is they share technology, they share tools, and they can adjust product offerings because some of the products share aspects within the vehicle. They can adjust a lot quicker. Another aspect of that is smoothing. So how a line can be balanced across station to enable scalability when going forward. I.e., if the whole line is smoothened or balanced in terms of time, all stations can adjust with peaks and troughs of different bespoke options. And likewise, initially mentioned, the modular design is very block structure. The second aspect of scalability is really the logistical supply chain. Utilising different models, you can be able to react accordingly to market orders, i.e. you don't want to be buying in bulk or delivering in bulk, you want to be delivering and buying in small batches, and likewise with them being delivered to your manufacturing facility. And this method helps with both the supplier and the manufacturer ramp up production very quickly, because you can predict on a very unit scale. Some other strategies that are used within a scalability model within manufacturing are direct line feed, kitting and supermarket strategies. Or a combination of all three help with the flexibility of the production system. We also utilise Rolls-Royce Motor Cars tracking component system, and what this enables is an accurate reflection of stock levels and stock counts. So being able to recognise when a system digitally is going to run out of material, that's can help with understanding what your future requirements will be. And likewise, not only stock is important, but DPU trends, so defects of the vehicle. How digitally can you predict and scale your business to react to expectations in defects coming off your production line? And the third aspect of scalability really is on the efficient and circular use of resources within your economy of manufacturing. So that's how you can, or how you as a manufacturer use resources and design waste out of your system, recycling, reuse, those sort of aspects. Or whether or not substitution. So can we use a different material that has been used before, or can we use a different material that maybe we wouldn't have thought before, that could be one aspect of changing your business quite rapidly. One of the most prominent aspects within Industry 4.0 is really cyber physical production systems. And what I'm going to do briefly is just to find out what that actually is. It's going to be quite a complicated technology. So what CPPS is, it really denotes a system where mechatronic components are coupled to a smart logical entity that enables these factories to enable such units to interact in an adaptive way, and is considered one of the cornerstones of what is perceived to be the fourth industrial revolution. In the recent traditional views of what a CPPS system is really how the physical, so the robot side, interacts with the cyber systems, so how you would design a production system on with CAD, and how that would transaction into the physical. However, we're starting to see a slight change in this, and the modern perception of it is really how, with these established cyber systems, how they're starting to interact more on a human basis, and how they're interacting with a human physically rather than necessarily one another. One such way, one thing that's also quite prominent within Industry 4.0 is big data. So we have, as a culture within Western and I suppose the Eastern manufacturing, is the collection of data. We're starting to collect data not only in manufacturing but within society, and to be able to control that is quite a big task. Big data can really be categorised into 6 criteria. One being volume, so the amount, as I mentioned, the amount of data we are collecting is excessive. The variety, so data is starting to see different types, different forms of data. Velocity, so the speed in which we're collecting data has never been as fast as it is now. The veracity, so the degree to which data can be trusted. So whilst we're collecting data, is it accurate? Is it what we want it to be? Value, so just because we're collecting data within a manufacturing environment, are we utilising it or are we wasting resource? And variability, so the ways in which the big data can be used and formatted. So that sort of pairs in nicely with variety. In the second section grouping is just because we're collecting different types of data, is one useful or is one not? One prominent method of collection of data within Rolls-Royce Motor Cars is radio frequency identification. It's in conjunction with wireless communication, has been used predominantly within the identification of products, parts or objects, because it is a non-contact technology. So it works within the electromagnetic range and radio frequency portion of the electromagnetic spectrum, and certainly within Rolls-Royce we've utilised it to identify vehicles. So each vehicle will have a tracker on it, and there are a system of scanners or antennas throughout the production system that communicate with those tags, and it makes it a lot easier to track down those vehicles. Another area in which we've used big data has been certainly within the supply chain, or the management of the supply chain. So we have an ERP system, SAP ERP system, which is an enterprise resource planning. So like I mentioned a couple of slides ago about the prediction of stock control, big data has been prominent in such management.
As already been touched on by Christian, cyber physical production. It's basically a monitors controlled system using computer algorithms, and it's tightly integrated within Rolls-Royce motor cars assembly. Another concept that's used is through the RFID systems is NFC, which stands for Near Field Communication. This basically is a controlled access point for several important areas within the assembly line and also within other technologies within Rolls-Royce motor cars. This is controlled by data access, which is governed by the associate's card. Key point of this is one, it's secure, but also tracks who and when accessed that component, how long it's been there for, and because there is no physical contact to it, it's very hard to circumnavigate a security measure. It's simply reading card that's secured onto the associate's data. So again, any key components or any new parts in development, we can help control the access to that area without affecting the infrastructure of Rolls-Royce motor cars or the production environment at all. Obviously, with everything like this, it generates yet more data. Everything we seem to do will collect more and more. And as we progress through the Industry 4.0, the amount of data collection is at unprecedented levels. At the moment, there's over 1 billion gigabytes of data stored within the cloud system. The reason we use a cloud system, it's not feasibly possible to store that amount of data in a single location on site in any business, which means it has to be secured it has to be stored in a very secure environment. There are different platforms that could be used as PaaS, which is the platform as a service, LaaS, which is infrastructure as a service, alongside SaaS, which is software as a service. These different satellite locations, they normally resemble, or the modern ones now resemble effectively a warehouse, where the data is stored within there on various servers. They are incredibly secure as well from cyber hacking or any other types of outside involvement. Which is key to managing the production system itself. The self-optimization of a production system is governed by its ability to transform input such material, monetary resources and know-how into physical products for the customer. The organisational elements, such as production planning and control, are included in mechanical functions. This again ties in the smart factory ethos that's being driven and operated within Rolls-Royce motor cars. With every bit of data being gathered, obviously cyber security is the key paramount to everything. The key thing to remember though, there is no absolute protection against hackers and abuse or feasible steps. So we have to be as robust as we can. Quite often, the weakest part of the system is an email or a link added onto an attachment that's already trusted. So cyber security at the moment is the key risk to a lot of businesses. There are several different types of encryption that can be used through the protection. I mean, Triple DAS was designed to replace the old data encryption system because it was found out that the old system, the old algorithm had been broken a little while ago, and data could be easily accessed without showing any electronic footprint of people going in there. It's okay doing all this and doing every step to protect that we can, but we have to make sure the training is up to date on all associates, again on new products, technologies, and also looking for future productivity. A lot of these issues have been referenced in the Engineer that was published in September 2019, where it understands that going forward and the closer we get to Industry 5.0, these are the key aspects that need to be protected at all costs. For one small item of data being taken or training not being completed, it risks issues in many levels, not simply point of fit. It could risk passing something on to a customer. So with the training, we have to make sure that everything is validated, recorded, and then revisited as well. There's no point introducing a concept or a new technology and then relying on the tribal knowledge being there Unfortunately, people move on, they progress, they leave. So we have to make sure that the training is a key focus from day one and it's an integrated part of the business.
So really what I want to briefly go through is some factors for consideration when transitioning from Industry 3 to Industry 4.0. As I mentioned, Industry 4.0 is about big digital data sets. And with that comes the concept of data analytics. And that's really how do we take the information that we've just captured, analyse it digitally, and with our algorithms to present the information to the end user, in this case humans, within the manufacturing to be able to action decision. Some of the examples that we've used data analytics are within Rolls Motor Cars. On the right you can see the topmost image here is a visualization of the paint shop and the coordination of the vehicles. There's numerous amounts of data that's collected to be able to track this, and it's live, it's real time. And with this, some of the production process boards and process feeders can manipulate the vehicles to where they need to be. Within assembly, we've utilised or started to utilise virtual reality. So whilst a picture paints 1,000 words for a process on how to build a car, video is starting to become more prominent, and on top of that, embedding video within training is quite useful. Whilst that has been mentioned, something that's come around quite recently with regards to processes and visualization are some of the standards. So we have some of the internationally recognised standards such as IEC or ISO, the International Standard Organisation, who have set out a section of industry methods, best practices on how a manufacturer or production facility analyses data. One example of here that I've put on there, which is on the safety instrumented systems, so the functional safety of processes, certainly with regards to digital, which I won't expand on, but that's one example, and that links in quite well to API, which is the application of program interfaces, and how visual programs are developed to enable training. Within some other factors within manufacturers that need to be, some other factors of consideration for manufacturers are some of the issues that are associated with Industry 4.0. Quite a lot of individuals, and you might have heard before, attribute the concept to getting rid of jobs, which isn't the case. It needs to be presented that yes, it might introduce skill gaps because you're starting to develop your manufacturing industry towards automation, and therefore the requirement for the likes of technicians and software engineers might increase. That needs to be presented alongside the idea of efficiency introduction.
I think the other two are self-evident, so that's okay.
Good.
Just touching briefly, because we've covered a lot of these points previously. From a supplier's point of view, as Industry 4.0 progress, they've had massive advancements, and through digitisation and incorporating the other technologies that relate real time with Rolls-Royce and other facilities across the globe. It helps with the flow of parts and also the integration of parts as well. As Christy mentioned earlier, we use an RFID technology so we can track where the cars are and when. So when we are running out or there's an old part that would no longer be required and a new part coming in, we can help predict the integration points as that is required with the assembly. Hopefully without any interruption to the process flow as well, and it also gives us a clear cut-off as to when that new component was fitted into a vehicle in case any issues do arise from that further down the life cycle of that part. Cognitive computing also comes into the technology as well, because like I say, as we are progressing through 4.0 and everything else is self-learning, and also a lot more human-computer interfaces are now becoming part of everyday business, whereas previously, yes, we had robots and other systems available, the technology wasn't there to work alongside human resources.
I'm going to briefly talk about blockchain, which is an emerging technology within towards Industry 5.0. Blockchain is really a technology that's built upon P2P. I won't go into the jargon of it, but the effective use of blockchain is really how data has gone really from a centralized control unit to a decentralized controlling. So data transactions are stored within a chain, and those chains, once they're transacted between certain modules, like two different computers, are stored on both. So both have a copy. It can't be tampered with, and therefore can't be arguable. It's one technology that's come about quite recently, but one to watch out for. Trends within Industry 4.0 and moving on towards Industry 5.0, some of the stakeholders that are looking in on this are non-profit organisations. One of the most obvious being governments. They're starting to recognise the importance of manufacturing. So within the UK, we've been known to shift manufacturing overseas, and we're starting to see now that maybe that wasn't the best ideas. We're starting to bring it back into the UK, and that's quite evident through some of the grants that the UK government has started to offer out to businesses and manufacturers to entice them into investing into automation and robotics further. Likewise, within research, scientific and research-based institutions, these grants are attributed to them also, which helps towards the future talent pool of the UK.
Very good.
Further trends of manufacturing and the factors shaping Industry 4.0 really has to be looked at harmonisation of human intelligence with AI and cognitive computing. So just as a brief overview, artificial intelligence is very, or can be considered dumb, whereas human intelligence is, you utilise common sense, you utilise judgment, creativity. Moving forward into cognitive computing, that is really a separate concept from artificial intelligence that still operates within programming and the robot sphere, but it tries to pair off what human intelligence is and tries to evolve that into the digital sphere. And with that, there's four concepts and principles of cognitive thinking and computing that encapsulate it. So the first being learn to improve, second build speed and scale, third being collect human intelligence with the interaction of them, and fourth, interaction in a natural way.
Okay.
And to briefly conclude what we've discussed so far, some of the major impacts of the industrial revolution going through at the moment. This has been building on the widespread availability of digital technologies that have been a result of the third industrial or digital revolution. The fourth industrial revolution is driven largely by the convergence of digital, biological and physical innovations, such as artificial intelligence, augmented reality, robotics and 3D printing. They're rapidly changing the way that we create parts and implement them. Also, the cyber-physical architecture is a big influence. Single-base architecture system better allows the integration due to tribal knowledge already attained through previous concepts. VR and AR integration can improve every step taken through from Industry 4.0 to 5.0.
When really reviewing the main factors manufacturers must consider when transitioning from Industry 3.0 to 4.0, the management and recording of data is seen to take up a prominent aspect for consideration. Similarly, with the recent developments of GDPR and the control of personal data, manufacturers must ensure that all data they gather is relevant, controlled, and importantly, secure from external or internal incursion. And as a final point, within the luxury automotive market, ever-increasing demand for personalised vehicles is being seen. Rolls-Royce Motor Cars must therefore pay particular attention of how their bespoke product offerings remain commercially available whilst investing in automation to remain effective and competitive. They, more so than ever, more so than any other automotive manufacturer, must be aware of the cognitive, collaborative technologies that is being seen in what is considered to be the fifth industrial revolution.
Thank you very much. I just wonder, I've got a clarification point. So you spoke a lot about the Internet of Things, and you spoke about cyber physical production systems. So I think, and I'd like to confirm this, what you've said is, so the Internet of Things at the moment are fairly immature devices that have some communication to them, but they will develop to include more and more cyber physical production systems themselves. They'll actually become, and in that, this cognitive collaboration will expand. Is that a fair interpretation of what you've said?
Yes, I mean, the Internet of Things would be really the basic within a manufacturing facility
At the moment.
at the moment, and then CPPS and the cyber physical production system is a bolt-on or addition, a supplementary technology that will move us forward.
Thank you very much.